Hi, it's Richard in the Old Okie Workshop. Everything in the workshop has a place and everything is perfectly in its place. And that means the cars that park over on the other side of the workshop, they've got to be perfectly parked as well. Like this.
Perfect parking every time.
How'd yours come out?
Perfect.
See. All right. That's pretty good. Let's check him back. So there you go, perfect parking every time. If that's what you want to do, there are 3 methods to do it. This video is going to cover method 0 and method 1, and there's another video for method 2. So what are methods 0 and 1? Well, method 0 is very simple. You just simply go to the point on your garage door ceiling that's directly above the windshield of your car and make an attachment and hang a tennis ball down, and it just hangs there all the time. The disadvantage to that obviously is that it hangs there all the time. So if you want it to go up and down, one of the ways to accomplish that is with the actual garage door motion itself. So you can hook it to the garage door somehow. So that's what method 1 and method 2 are all about. So let's take a look at how we would do that using method 1. Here's a side view of method 1. There is a garage door here, and the line is attached to the top of the garage door. The line comes over here, goes through the screw eye attached to the ceiling, attaches to a tennis ball. So the idea is that the garage door is going to go up, the tennis ball is going to come down, and I'm going to drive my car in here. And the idea behind all these is that you place the tennis ball at eye level when you're sitting in the car, and you drive up to it, straight up to it, be centered over the steering wheel. You drive up till you touch the tennis ball, and that's where you stop. And so you're good left and right, and you're good as far as how far into the garage you've driven. And this distance here is about 13 feet. That's about how far my car is going to drive in when it windshield touches this tennis ball, and that's where I want to park. Here's another side view of method 1, and in this case the garage door has gone up. So garage door was over here, it's gone up like this. The garage door is about 7 feet, so therefore it has traveled about 7 feet up this direction, and then that means that the line has gone 7 feet and the tennis ball has gone down 7 feet, and the problem here is that it's almost down to the floor. We only want it to come down about 4 feet is how far we want it to come down. So we got to figure out how, when the garage door goes up and the line goes 7 feet this way, how we can get this tennis ball to only come down to about 4 feet. This is an overhead view looking down on the garage door, and it's here it is in the down position. Garage door goes up to the up position, goes this way. You can see here by the dotted lines, goes 7 feet, of course. Now here's the screw eye over here, 13 feet in, and what we want to do is we want to attach this line instead of directly over here, because we know when the door goes 7 feet, the tennis ball goes down 7 feet. We want to put it over here somewhere, and the question is, where is this location? Now here is the line now attached over here going to the screw eye, and the tennis ball is down there. So as the garage door goes up, it moves 7 feet, and this line now is in this position, and so we have a distance A originally, and then a distance B where we finally wind up, and we want the tennis ball to go down 4 feet, so we want the difference between A and B to be 4 feet. So A minus B is equal to 4 feet. And we're going to have to figure out where this position is based upon that. To solve this problem, we're going to construct two triangles. We know that this distance is 13 feet to the screw eye, so we'll construct a triangle here that has a base of 13 feet. And then we know that the door is going to travel from here to here. That's the distance of 7 feet. Obviously, this is 6 feet. So what we got to do is to figure out straight from this screw eye here, how far down the door do we need to place this attachment? That's the problem. And that distance is equal to x. Okay, so we got to solve for x. It's trigonometry time. Remember studying the Pythagorean theorem when you were in school? Remember when you asked your teacher, what am I ever going to use this for? And your teacher said, you're going to use it to figure out where to attach that string so that tennis ball goes down the right amount so that you can do perfect parking in your garage just like Richard. Well, here's the solution, and I'm not going to go through this. You can pause the video and look at it. Or you can take a look at my website, oldokiworkshop.com, and you can study over this solution. But it turns out that x is 13.34 feet, which means the connection point at the top of the door has to be 13.34 feet from in line. In other words, from in line from here over to the door, we've got to move down this way 13.34 feet in order to get that tennis ball to go down 4 feet when the door moves 7 feet. I'm now standing directly under the tennis ball location, and right down there where that blue tape is straight down from where I'm standing, and that piece of blue tape you can see right there between Ohm's law and pi, okay? And we know that the attachment has got to be over this direction, so we move over here 13.34 feet, that was our calculation, and this is where the attachment actually has to be. I've moved over to the right now, and there's the tennis ball I was standing directly underneath right there, and you can see that there's a fluorescent light there, and then there's a garage lift, and then over here is where that attachment needs to be down there. So that is a problem because those things are in the way. Here's where the screw eye goes, and then here's the line that's running down here, and we already saw that there's a garage door lift in the way, like here. So you got to get around that somehow, because this line is not going to be able to swing back and forth where that garage door lift is, because it's attached to the ceiling. So you're going to need another screw eye over here somewhere like this. And then that means the attachment, the line, is going to run from this screw eye over to this one to get routed around the garage door lift, and then it's going to have to come down here like this. Well, that changes this 13 feet, doesn't it? So now you have some new dimension right here that you've got to figure out what this distance is for this line to be over this way. So now these two lines, they don't go like this anymore, they go up like this. But it's the same geometry problem, so you've seen the solution, you know how to do that. One of the issues involved is how high above the floor is that line, and if you attach it to the silver bar there you see, which is the top of the garage door, that's where you attach it. You're going to be about 16 to 18 inches below the ceiling and about 7 feet off of the floor. But you can extend that line up by placing a bracket. I've just placed a piece of wood up there with a spring clamp to give you the idea that you can construct a bracket there, attach the string to the top of that bracket, and then you raise that about a foot, maybe 14 inches higher than if you attach it to the actual top of the door. Now as the door goes up, that piece of wood or arm, that's going to go up as well, and it's going to hit the ceiling, except for the fact that the door starts to bend over this way, right? So the tip of that will start coming this direction, and you just got to make sure that it clears the ceiling. you've got enough information now to figure it all out and know where to place everything and where to make the attachment. And one last tip, out there in the garage you could see obviously that these lines are going to be running underneath the ceiling, and they can get snagged and they could get broken. And so what I would do is I would take a clip like this and I would attach this clip to the top of the garage door where it needs to be, right? And then I would clip the line into this little clip. Then over here we have our screw eye, and then if this line gets snagged by the end of a broom or a piece of plywood you're hauling in or anything like that, instead of the line breaking, the line will come out of this clip. Now when it comes out of this clip, which by the way I call a fuse, this is a little fuse, see? So the fuse blows, the line comes out, and then the tennis ball is going to fall out. So when the tennis ball falls out, then you're going to have to restring it through there. But not so fast. I put a fail-safe in there, and that's this ring. So this ring is placed on this line. This is the line that's going down to the tennis ball now, and this is the line that's in our example was 4 feet long. So if this line breaks or comes out of here or whatever, this tennis ball will simply fall down to its position, and this ring will keep it from the line from coming out of this screw eye. So that's my last little tip. So there you go. Perfect parking every time with method 0 and method 1. If you want to see method 2, there's a video on that. Take a look. As usual, you can find everything at oldokiworkshop.com. Thanks for watching. See you next time.